大家好. Hi everyone. Good after. Good afternoon. Maybe is this easier? Yeah, I'm too tall. Are we having a good conference? Yeah. Excellent. It's nice to meet you. My name is Osborne. I'm from the Linux Foundation, and today I'm going to be sharing some research that I've done with colleagues at the Linux Foundation, but also from the wider Generative AI Commons. I don't know if Annie Lai is here. I don't know, but does everyone know Annie, organizer? Annie is the chair of the Gen AI Commons community. And anyway, so the Model Openness Framework is a product of collaboration in this community. And I'll be talking about how it can be useful for addressing some of the new rules and regulations that are emerging around artificial intelligence technologies, in particular the AI Act in Europe. So before I get started, I want to say two things. Firstly, at the end, I will be handing out stickers. I might forget, so please, if I do forget, please approach me and I'll happily give you one. And the second thing is, I know this is a very big room, but I would like it to be interactive, so let's just imagine we are in a small classroom and I'll ask you some questions, so please be prepared to get involved. On that note, let's get started. So just so that you know who I am, this is my background. So I think about open source AI governance from two perspectives. The first is as a researcher with a PhD in data science. I also was in Beijing before at Laoshe Zhou Minghui's lab at Beida, which was a lot of fun. And previously I worked in AI policy at the UK government, so I also think about this from a policy perspective. So today's agenda is about the Model Openness Framework. Please raise your hand if you have heard about this framework before. Again, so I can see. One hand, two hands, maybe. Was anyone in Professor Wang's presentation yesterday? No, he spoke about it as well. So yeah, today I'll be telling you about this. But let's start with some background. So every year, my colleagues and I at the Linux Foundation run a global survey called the World of Open Source Software Survey. And then from this global survey, we create regional reports. So I co-authored the European report this year. It's a combination of survey findings from Europe, as well as expert interviews. We interviewed 22 experts. And an interesting finding was, every year we ask open source software developers of a list of technologies, which one do you think is the most important that we open source? And this year, the number one technology was machine learning and artificial intelligence, which is exciting, right? But the question that I ask is, how exactly does one open source machine learning and or artificial intelligence? Who here thinks that they know how to answer this question? Please raise your hand. Oh, come on, at least one person. No? Okay, well, maybe you're just as confused as I am. But it's not a trivial question. It's important because the Artificial Intelligence Act, which is the regulation of the European Union, kicked into effect on the 2nd of August this year. And this act has exemptions for AI systems and AI models that are released under free and open source licenses. So just to give you more specifics, so there are general exemptions for open source AI in research and development contexts. So it says, the regulation does not apply to AI systems released under free and open source licenses, but it does not say which licenses or how, what is an AI system and which components comprise an AI system and which licenses are used for them. Unless they are placed on the market, so that means they are commercialized, or if they are high-risk systems. So yeah, this is the question I'm asking myself. Which components of models or AI systems should be released or must be released, and with which licenses. Furthermore, there are some limited exemptions for what the regulation calls general purpose AI models. We can think of these as foundation models. And so it says AI models that are released under free and open source licenses that allows for access, usage, modification, distribution of the model, and whose parameters, including the weights, information on the architecture, and on model usage, are made publicly available. So yeah, this is encouraging, this is exciting. It's trying to protect the 4 freedoms of open source. This is, ability to use, to study, to change or modify, and to redistribute, as long as it's in research and development. But similarly, there's a question is, are model parameters enough for access, usage, modification, and distribution? You might say, to a certain extent, yes, right? But beyond model parameters, we might be asking, which components do we need to release to enable access, usage, modification, and redistribution? So the TLDR of this is that we need some guidelines for AI model openness and licensing ASAP. And one of the reasons for that is that we have regulation. And if we can learn from previous regulations in the European Union, like the GDPR, they're going to have this new regulation for artificial intelligence is going to have what they call the Brussels effect, that most of the world will be following this regulation. So it's very, very serious, and it has implications for us as AI researchers and developers. But we have some good news, which is that we've already made a lot of progress in 2024. We haven't got the solutions yet, or final solutions, but we're making good progress. And just to mention 3 examples, on the bottom right, you can see the open source initiative. For 2 years, they were running a co-design process involving experts from all around the world, including from China, to figure out what is open source AI. Please raise your hand if you're familiar with this initiative. Just me? Let me walk over here. Was anyone aware that the open source initiative was defining open source AI? Please raise your hand. I see Alan nodding. Okay, two hands. Well, they released their release candidate for this definition on the 2nd of October, this month. And it's a bit, there's a heated debate about this definition because they're trying to create a binary definition. I myself have been involved as a volunteer and a contributor in trying to figure out if we can define open source AI in a binary way. And people have very strong opinions about this. And some people want a minimal definition, and some people want a very, very strict definition of what can be considered open source AI. Then here we have a framework made that came out of a meeting called the Columbia Convening, and it was organized by the Mozilla Foundation. It was in New York at Columbia University, which involved experts from many different organizations, including the Linux Foundation. And it creates basically this framework of what are all the various layers of the stack and the components of models. So look at this green box here. You might not be able to see it, I'm sorry, but you have various data sets, code, and model weights components that they say comprise a foundation model. And then there is, last but not least, the model openness framework, which came from the GenAI Commons, which I co-authored. And so for the rest of this talk, I will be focusing on the model openness framework. So here it is, it's on archive. We have been, I think we've got the 5th version on archive now. We're kind of releasing it on in a non-systematic way, but roughly once a month based on feedback that we get from model producers, model users, and members of the community. So if anyone here has been part of giving feedback, thank you very much. And as I mentioned, it's a product of collaboration in the GenAI Commons community, which Annie Lai is the chair of. It was started last year. There are already over 200 active members from over 80 organizations. And if you want to learn more about it or get involved, you can scan this QR code. And just in a nutshell, what the GenAI Commons community does is it's organized in 4 work streams that focus on models, applications, and data. Frameworks, this is the working group that I'm a member of. Education and outreach, and finally, responsible AI. So there's a lot here, so if that sounds interesting, please join us. But okay, let's focus on the model openness framework. So just to set the scene, you know, it's been very exciting seeing the emergence and commercialization of generative AI technologies, you know, whether it's from chatbots like ChatGPT to the various models that we've seen in this room today and yesterday. We're making a lot of advances, but there are a lot of concerns about limited transparency and safety of frontier models, many of which are black boxes. And many of these open source AI models are not actually open source. As I mentioned, we don't really have a definition of what is open source, but we've also seen a lot of open washing, where model producers have been releasing models with restrictive licenses. I'll mention some later on, calling them open source, but they're not, because the 4 freedoms of open source, to study, to use, to modify, and redistribute, were not guaranteed. And one thing I often hear when I present the model openness framework to companies, I hear from their legal team and from the IT security team that they're not touching many models that are available on platforms like the Hugging Face Hub, because the security team say, well, we can't do due diligence. You know, we can't vet these models. We don't know what they're trained on. And then the legal team say, you know, well, similarly, we don't know what they're trained on, and it could be, for example, copyrighted material, and we could get in trouble. And the regulations are not clear yet about who would carry the liability. So anyway, so there are a lot of problems that are hindering adoption of many of these frontier models that we're all quite excited about. So this is why we've developed the model openness framework, and there are basically 2 benefits. The first is for model producers. It offers guidance on how to enhance model transparency and reproducibility while allowing permissive usage and hopefully also facilitating adoption. And for model users, it provides clarity about which models are suitable for commercial use and with which restrictions, if any. As I mentioned, models have been released with various licenses, and I should say these licenses are used for model weights, right? And one of the things that we're trying to figure out as a community is it appropriate to be using open source software licenses for model parameters? My co-authors and I of the model openness framework don't think that's the case, because model parameters are actually data files, right? Weights and biases, which are not software. So even though permissive licenses like Apache 2.0 and MIT you know, protect kind of users from any kind of liability, the contents of these licenses are quite specific about rights and freedoms that you have regarding source code of software. So perhaps we need to develop new licenses for model parameters. Then also you have a number of new proprietary and restrictive licenses. Are you familiar with the OpenRail license? No? So the OpenRail license is a responsible AI license developed by researchers and developers at Hugging Face, and basically creating restrictions on use, saying you can only use this for responsible use cases. So I think they have noble intentions, but the open source, many open source practitioners are not comfortable with these restrictions. Then you have the Llama 2, or the Llama Community Agreement license by Meta, which has restrictions on responsible or irresponsible uses, but also restrictions for competitors, any company with, I think, more than 700 million users or customers. So they say, okay, everyone can use our Llama models except for our direct competitors. So this is not exactly an open source license. Anyway, so there are a bunch of different licenses that are out there. There's a lot of confusion about which licenses people should be using. The vast majority of licenses, of models on platforms like the Hugging Face Hub don't even have a license. So this is something that we need to figure out. And this is one of the things that we tackle in the model openness framework. So the first thing I should mention is that we take deep learning models and we break them down into 17 components, categorized into code, data, and documentation components. And here you can see them. I think something to point out is that model weights and the model parameters are considered data components rather than code components. So there's a lot here to see. Maybe will the audience have access to the slides afterwards? Okay, well maybe. No answer. And here in the yellow boxes you see the components that are required for foundation models or general purpose AI models in the AI Act. As you notice, it's not many components of models. Maybe you can say it's a light touch approach. But what we say is, the AI Act maybe should be going further and be requiring more components to be released for these general purpose AI models, these foundation models, which are very powerful and promise to have widespread adoption. And so we have these 17 components, and we don't say that model producers have to release all of these. Instead, what we do is we created a rank classification system with 3 tiers, which is based on the principles of open science, in particular completeness and openness. Openness is a binary property. Is it released or is it not with an appropriate license? And completeness is about whether all the required components for the class in our 3-tier classification system are released. So with that knowledge, I'll introduce the 3rd class, and this is the base class, which is just providing the model, and this is what a lot of most of the models that we see today fall into this tier. So this includes the architecture, the final model parameters, final checkpoints, a technical report or a research paper which explains how the model has been trained, maybe some, no, I shouldn't say maybe, certainly evaluation results, and some documentation, namely the model card and the data card. And an optional component is sample model outputs. Then going forward, we have open tooling. This allows the users of these models to kind of roll up their sleeves and to play around with these models a bit more. So we have all of the class 3 components, but we also add the training, validation, and testing code, inference code, evaluation data, and any supporting libraries and tools. So this is the open tooling tier of the model openness framework classification system. And the kind of the gold standard, which serves the interests of reproducibility, but it's very, very, very demanding as a tier, and there are very few models that are out there nowadays that would classify as class 1. Involve all of the class 2 components. That means also all the class 3 components, including a research paper, the data sets, which is the kind of elephant in the room, the data pre-processing code, intermediate checkpoints and optimizer states, and metadata as an optional component. So what you've seen so far, just to kind of summarize this, is we're trying to give guidance to people, to developers and users of models. Okay, you have a machine learning model. How can you break it down into constituent components? We say there are 17 components. These include code, data, and documentation components. And then there are various levels in which you can be releasing them, or as a user, various levels that you can expect from the producer. So hopefully this is giving you kind of a structured understanding of model openness. Then the next thing we do is, for all these 17 components, we recommend appropriate licenses. So for the code components, for the data components, and then for the documentation components, we make recommendations. Our recommendations are not exhaustive. They're just a starting point. And with certain components, in particular model parameters, the weights and biases, we still have to have a conversation as a community about, what licenses are most appropriate. The least we can say is that we think that open source software licenses are not the most appropriate type of license for model parameters. Now, I'll just talk you through some benefits for model producers, and then subsequently I'll tell you about the main benefits for model users. So the first one is that if you're, as a model producer, you're releasing more components, you're facilitating adoption, and you can build a vibrant ecosystem around your models, with people using your models, fine-tuning them, and contributing back. Oh, there's Annie. I just mentioned you 3 times during my presentation. The second benefit is you can improve the performance and safety of your models through this adoption. It's similar to Linus's law in open source software, right? The more people you're using it, the faster you're going to find bugs and problems, and people will be reporting these back. Or maybe, creating new innovations and sharing them back. So if you're the model producer, you can benefit in many ways through facilitating this adoption. And the final benefit is, complying with regulations such as the AI Act, which has just come out. So to summarize, the model of openness framework effect for model producers is that, hopefully they will release more components, they'll use appropriate licenses, and as a result, encourage more adoption and collaboration in the open source AI community. Now, with regards to the model consumers, the first thing is that you'll have more clarity about how models have been developed, right? Second is that you can use models, enhance models for your own purpose. Earlier I mentioned, the legal teams and the IT security teams at companies who are very hesitant to adopt these models. I think with more information, more transparency, you're going to be able to encourage that kind of adoption downstream. And then the third benefit is, facilitating collaboration amongst the community. Now, of course, there are some limitations. Here I've just mentioned a few. The first is that it's specifically tailored for deep learning models. It may not be comprehensive for some other approaches, for example, reinforcement learning, but it's easily adaptable. And maybe we should be making a subsequent model openness framework for reinforcement learning or various approaches. The second is it's going to be challenging to get model producers to release some of the components that we mentioned, for example, the training data sets. And this is where the open source initiative has been, this is a problem that they've been wrestling with for some time, because there are various types of data sets that go into the training of these models, right? So, first category is maybe internet data. You can scrape the whole internet, the public internet, and get that data. The second might maybe commercial data that companies have, and they don't want to be sharing that. There are a whole range of legal issues about copyright, about data protection, protection of customers' information, and so on. So it's going to be hard to get that out. And so we recognize that it's going to be hard for models to reach our kind of gold standard open science tier. Maybe that will just be the pursuit of academic endeavors and research groups. But so yeah. Another limitation is that we don't address issues of bias, safety, and the harms that these models can create. That's very, very important research. We're just focused on the question of model openness and completeness. And lastly, we might be overlooking very important nuances. So if you see any nuances that we haven't captured, please feel free to share them. Come find me here, or join the GenAI Commons community and join the conversation. We're not kind of pretending like this is, perfect and finished work. It's an ongoing collaboration. And so, what about adoption or implementation? So there are 2 things I want to highlight. The first is the spec, which is coming out soon, which has been spearheaded by Arnaud, who is the co-chair. He's not here at the conference, unfortunately. And secondly, with the model openness tool. So here they are. So the MOF spec is coming out soon. As you might expect from a spec, it says for these 17 components, what should be released and with which licenses, what must be released with which licenses, and what can be released with which licenses. So it's a much shorter version of the model openness framework, and designed to be as practical as possible for model developers. And then we have the model openness tool here, which is an ongoing collaboration to create a catalog of open models and provide tools for producers to evaluate the openness and completeness of their models, as well as for users to understand the openness and completeness of models that exist out there. So I'll talk you through some examples. So the landing page is the catalog. So this is, here you see a few rows, for a given model, you'll see the classification it has received, the last date it has been updated, and as well as a badge. Then you can also evaluate a model. So let's say you've been developing a model and you want to see how it ranks in our classification system. So this page asks you to enter the licenses of the corresponding components and then evaluate it, and then it will produce the evaluation, give you a score, and also a badge which you can use and put in the repository, whether it's on GitHub or Hugging Face or some other platform. You can also submit a model to the catalog. We invite many model producers to do that to help us make a more kind of comprehensive catalog. And yeah, so that's it. So just before I wrap up, here are final invitations to join the GenAI Commons, which Annie Lai is here. So if you have any questions about that, please approach Annie. She'll give you much more detailed answers than me. And check out the MOF. We'll have a new version going out next week with updates from the spec, and the spec will be going out soon as well. So we're hoping to facilitate implementation and adoption as soon as possible. So on that note, I just want to say thank you, 谢谢, for listening, and yeah, enjoy the rest of your conference.